Hi, so today we're going to talk about the difference between mass and weight. It's one of those things that's really important to get down and to have a firm understanding for. Not always the easiest thing to know because it's so different and it's something we've not really thought about very much in the past, probably. So the more mass an object has, that gives it greater inertia. And I know we've been talking about inertia a lot. Inertia means it wants to keep doing what it's doing. So if it's moving, it wants to keep moving. If it's not moving, it wants to stay at rest. If it has more mass, it's going to want to do that even more. It has greater inertia, and more force is going to be required to move its state of motion. So if you have one of those little wiffle balls, you know, those really tiny little wiffle balls, and you try to move it, it's pretty easy because it doesn't have very much mass. If you have a bowling ball, however, it takes a lot more force to get that to move because it has more mass, therefore it has more inertia. More mass means it doesn't want to change its state of motion even more. So, a couple of things that sometimes get confusing. Mass is not equal to volume. Volume is a measurement of space, how much space something takes up. And it usually is in meters cubed, centimeters cubed, or liters, which is a measurement of volume. Mass is measured in kilograms. So, I'm sure you've heard the old riddle, which weighs more, a pound of feathers or a pound of lead? We could say which has more mass, a pound of feathers or a pound of lead. The reason people think feathers is because it has more volume, but volume does not equal mass. Volume and mass are separate. Okay, so you could have something that has a really big mass and a really little volume, or something with a really big volume and a really little mass. Mass and volume are not the same thing. Now, mass and weight are also not the same thing. Mass is a measurement of the amount of material, or the amount of stuff in an object. Mass depends only on two things, the number of atoms and the kind of atoms. And I know we haven't gone over atoms yet, but you know what an atom is. It's a building block, it's the smallest particle that still has characteristics, blah, blah, blah. We'll talk about that later, but the important thing is that mass is a measurement of the amount of stuff. The amount of stuff. And it's only dependent on two things, the number of atoms and the kind of atoms. Okay? Weight, on the other hand, is a force. So it's a measurement of how the gravitational force acts on an object. Weight depends on where you are. It depends on location. So if you want to lose weight, go higher away from the surface of the earth. Like we live in a valley. If you go on a mountain, you'll probably find that you weigh less. So weight is gravitational force. It's a measurement of the gravitational force that acts on an object, and weight depends on location. Mass doesn't. Mass doesn't care where you are. You still have the same amount of mass, but you have a different weight. When I went on the zero-G flight, it was called the weightless flight of discovery. It wasn't called the massless flight of discovery. When I was floating around in zero-G, I still had the same mass, but my weight was significantly different. So think about that a little bit to help you get the difference between weight and mass. It was a weightless flight, not a massless flight. Mass, again, is the quantity of matter or stuff that's in an object. How much stuff you have. How much stuff is in you that makes you weigh a certain amount, that makes you have a certain mass. Whereas weight is the force due to gravity on an object. So weight has to do with forces, and mass doesn't. Mass and weight are proportional to one another at a given location. So they're proportional to one another. On the moon, that proportion is a certain number. On the Earth, it's a certain number. On Mars, it's a certain number. But in all three cases, that proportion is different. They're not equal to one another, but there is a relationship between them. In the United States, we say the amount of matter that something has is weight. So in the United States, we call weight and mass kind of the same thing. We shouldn't do that, but we do. It's measured in pounds. Pounds is a measurement of force. The SI, or System International unit for mass, is kilograms. That's the foundational unit. Now again, the root word is gram, but the foundational unit is kilogram. 1 kilogram is about 10 newtons, roughly 10 newtons, and 1 kilogram is about 2.5 pounds on the surface of the Earth. Okay, so it's going to change if you go to a different place. Remember, weight is dependent on where you are. It's dependent on location. Mass is not.